Hello everyone, myself Bhavna. I'm a researcher at Allen Institute for Artificial Intelligence, and today I will be presenting our work Entailer, answering questions with faithful and truthful chains of reasoning. This is work done with my colleagues Oyvind and Peter. The overarching goal of our Aristo team is to build AI systems that can systematically reason, explain, and continually improve over time. Pre-trained transformer language models show state-of-the-art performance on many NLP tasks, especially question answering, but they leave us wondering, why did system produce certain answers? So if they go wrong, it is very hard to fix them. Post hoc reasoning techniques like LIME have been proposed, but they explain the decision after it has already happened. So it's hard to go back and change it. Rationale-based explanations tell us the relevant facts for this particular reasoning, but they fail to show us how the conclusions follow from the premises. Here we aspire to build teachable reasoning system with two desired attributes. The first one is we should be able to understand why the system chose a certain answer. And if this is possible, then hopefully we will be able to correct the system's behavior by providing natural language feedback. In this particular paper, we focused on the first part, how to understand why the system chose a certain answer. And here we are envisioning a machine reasoning model that acts like a student solving exam questions. When the students answer the questions, they also produce the solution steps showing how they arrived at that particular answer. So when the teacher scores the answers, they can look at the solution and find out at what step the student went wrong or whether all steps were correct. In this particular project, we are asking the system to generate multi-step reasoning chains. For example, eruptions can cause plants to die. The system should be able to explain it with two or more premises like these. Eruptions block sunlight and plants will die without sunlight. Hence, I believe this hypothesis. Further, it should be able to refine its explanation by drilling down into one of the premises. So why do you think eruptions block sunlight? System should be able to produce the reasoning that eruptions produce ash clouds and ash blocks sunlight. Next, we ask, can we use existing language models to generate such explanations? Short answer is yes. We fine-tuned a T5 model to do backward chaining. So in this case, we can feed it a hypothesis and it can produce single-step explanation with two or more premises. And we can apply this model recursively on any of the generated premises to get more fine granular explanations. So the problem is solved, right? But such models can now explain any given hypothesis. So if I drop a glass on a bed of feathers, the glass will break. Our system is able to produce an explanation that yes, because feathers are soft, if something breaks, then it will shatter. Note that the premises here are fine, but they don't entail the hypothesis. Now, if we go to GPT-3 and try a few zero-shot prompts, it comes up with another explanation. The glass will hit the feathers and create a force on them. Feathers will then create a force on the glass, causing it to break. Note that the reasoning pattern itself is good, but it doesn't apply to the specific entity feathers in this case. So overall, in our analysis, we found that language models often hallucinate facts. They generate explanations that they themselves don't believe, and conclusions may not always follow from their arguments. Instead, here we are looking for truthful and faithful explanations, and there should be a way for users to fix the system's reasoning when it goes wrong. There are many different ways of achieving this. Meiotic prompting and chain of thought prompting, these works were developed around the same time as this paper. They focus on using GPT-3 as language model, and they address some of these issues, though not everything is covered. So in this particular project, we built a multitask DeFi model that can answer three types of queries. The first one is we give a hypothesis as input to the system, and the system generates one step explanation. This query can be applied over the premises, generated premises, to get more fine granular explanations. Now, any of the generated premises can be fed back to the system, and we can ask the question, do you really believe this premise? And the system scores it as true versus false. We can also put the entire proof as input and say, do these premises entail the hypothesis? And the system can score the entailment from multi-premise entailment. Now, once we have a model that can do all these three queries, how can we apply it for question answering? Consider a simple science question here. The force that holds Earth in orbit is A, magnetism, B, gravity. For each of the answer option, we can create hypothesis, construct hypothesis like this: magnetism holds Earth in orbit versus gravity holds Earth in orbit. Now we can sample multiple proofs from Entailer using the explanation generation capability. This can be done for each of the hypotheses. And now we can fire its verification ability to score each of the generated premise and also the entailment itself. The hope is that if we rank the proofs generated by the system based on its own confidence, it should be able to rank the proof for correct answer option above those for the incorrect answer option. Note that the main goal here is not better answer accuracy, because this is a much more involved reasoning task. And we already have state-of-the-art models for question answering. But the goal here is, while maintaining that answer accuracy, can we also um, see what the system is doing behind the scene? And in this case, when the system says I choose answer option B, we can immediately see what proof did it generate and believe for this answer option, and which other proofs it considered and did not believe. So when the system goes wrong, there is now a chance that humans can go and correct some of its beliefs or reasoning and improve the system further. So first, let us look at how did Entailer perform on question answering task itself. So here we are computing answer accuracy of Entailer versus end-to-end QA with T5 model. And for OBQA dataset, we observed that Entailer produces comparable performance compared to end-to-end QA system. We also observed that instead of greedy based decoding, if we sample multiple proofs and then select the answer, it gives a little performance boost. And when we did more fine granular proof generation, it didn't improve the score. So the only advantage of doing that is we can look at systems beliefs at a more fine granular level and correct them. Okay, so the next question we ask is, now that it can produce answers at a comparable accuracy, can humans understand its reasoning looking at the proofs? So here we asked human annotators. This was a blind study where they were shown explanations generated by Entailer and a baseline explanation generated by Tau. And users said that they clearly preferred Entailer explanations. Further, it was evident that for most of the questions, conclusions clearly followed from the premises. This is a good news, because now even if the system goes wrong in some cases, there is a way to correct the system, and that is the second part of my talk. So this is another paper that is being presented at EMNLP in poster session, but I'm giving you a glimpse of how Entailer can be used in an interactive setup to improve its performance even further. So here is an idealized dialogue that we are envisioning. Users can ask the system, can you pick up a penny with a magnet? And Entailer will rank explanations for both yes and no answer choices. It can come up with a wrong answer. Yes, pennies are made up of metal and metals are magnetic, hence I believe this. At this point, user can give a feedback and say, not all metals are magnetic. Copper is not magnetic, and ask it to try again. At this point, Entailer should be able to take human feedback and apply it on this question to come up with the right answer. Now, how can Entailer do this? So when it was trained for multitask in the multitask setup, it was trained to take optional context as input. So given a question without any context, it will generate and rank the proofs, but with relevant context as input, it should be able to both generate and score the proofs differently. It was also trained to disregard uh, distractor facts in context. So now let's see whether it is possible to turn this into a system interactive. So this is the memory augmented interactive framework that we explored. It's called TeachMe, where the Entailer model is assisted with persistent memory of user feedback. Given a question, Entailer can retrieve feedback from memory and produce its solution. If it goes wrong, user can give corrective feedback, which is stored in the memory. And when it sees a similar question, again, it can use this feedback to change its reasoning. Note that the model itself is frozen in this case. It is not being retrained, but the memory is dynamically updated as it makes errors. So this is how we correct the system's behavior. We found that both in real user studies and in simulated feedback, the system improved its test accuracy with such teaching sessions. So the takeaways are that I presented Entailer model that can produce faithful and truthful chains of reasoning. Users are able to understand and correct systems behavior, and such models can be adapted to new domains without retraining with the help of dynamic memory. Both these papers are being presented at EMNLP, and our model and data is also available on AI2 website. Thank you for your attention, and please let me know if you have any questions or feedback.